thank you all for your patience. Welcome to the our CAIS seminar series. I know some of you are here for course credit. Some of you are recognized as doctoral students in both computer science and also some social work doctoral students. It's great to see you all. It's my pleasure to introduce Hsing-Chi Hwang this afternoon. She's a new assistant professor here at USC in the Annenberg School for Communication and Journalism, and her research explores the societal impact of AI-powered technologies on work practices. In her past and present work, she focuses on how practitioners design, build, and apply AI to facilitate group interaction, produce creative content, and balance everyday wellness. Please join me in giving her a welcome. Go ahead, take it away.
Thanks, Eric, for the very nice intro. Hello, everyone. Good afternoon. I'm really excited to be here today at the CAIS seminar series to share with all of you a series of work that I personally found very passionate about. Some of the content that I present today, they are work that I've done in the past, but also include content that that are pretty much like ongoing work. So questions, comments, feedback, all those stuff, those will be great and very much welcome. Before I dive into my content, I want to maybe just kind of like do a quick survey here and then to get a sense of when people see the term human-centered AI, like whether you're actually studying, researching, or doing anything related to human-centered AI, what is your kind of like gut feelings in terms of how do we study or improve human-centered AI? What is your instinct reaction to that? Anyone have a thought of any? Yeah.
You need to talk to real people.
Yeah, exactly. So it's human-centered. So you want to study the human. And that my interest in human-centered AI, as well as a lot of my colleagues and researchers in this field, centers around that. And as someone who identify as a human-computer interaction researcher, there's a long history in FCI studying humans and how they interact with a piece of technology. And so, like many other fields, there is growing interest in focusing on studying how humans interact with AI-powered technologies. What are their experience? How do they behave and respond when they are handed with a piece of AI-powered technologies? So that's what we will be focusing on today, and as well as a lot of the work that's happening here in this field. And so when thinking about studying human feedback, studying human experience, studying human behaviors, I want to give you, first of all, a broad sense of what sort of insights can we get from studying things at individual level. So I'll start from, we can start from looking at, for example, people's mental model of AI. Conceptually, how do they understand, what are their perceptions, or maybe also misperceptions of how AI works and doesn't work. And so from there, you can extend to looking at how does a piece of AI technology support people's decision making. And by the way, throughout this slide deck, I'll use these like gray boxes to represent AI systems or AI applications just for the sake of simplicity and illustration. And from there, you can also consider cases where you look at human-agent interaction. For example, I'm sure many of you here, if not all of you here, have probably tried out using applications such as ChatGPT to interact with the application and then try to use it to help solve some of maybe simple questions or maybe harder questions such as like identifying bugs in a piece of code. And from there, you can also, when people study individual levels interactions, you can also look at how agents facilitate human groups. So for example, people who they're having a rich line of work looking at how AI agent can facilitate conversations, communications, or even team collaborations among small groups. And from there, you can also extend that to look at how this agents or any sort of AI applications facilitates the interactions among larger groups of human beings. Another active research areas that people have been looking at in this field also consider human algorithm interaction, which means we're studying how humans interact with, say, a piece of content on a large platforms, their behaviors, their interactions, then their behaviors, their feedbacks, then become new batches of data that got fed into an AI system. And then that output of the AI systems produce new content, new stuff outputs for people to interact with on the platform. So I hope all of these give you a sense of the wide range of things you can study and look at when you're studying and researching how humans interact with AIs at the individual levels. And you can do that, say, with interviews, you can do that with user studies, behavioral experiments, all those techniques that you probably have learned or heard from a research method course. And you can repeat this process to study a wide range of different AI applications or AI systems. And this has been kind of like the standard practice of how the XCI fields, or in general, people who are interested in human-centered technologies have been studying these applications and systems for a pretty long period of time. And so in terms of the process or procedures wise, there's not that much of a new stuff when we look at the AI space. However, there are increasing there's a growing body of work starting to reveal there might be differences and something unique about the fact that current state-of-the-art AI and their applications are deployed and implemented at mass scales. And when I say mass scales, that we're not just talking about, say, hundreds or thousands of people. That can be applications or large language systems that are implemented pretty much at the entire societal scales. And so there's increasing work starting to point out there seems to be limitations if we only look at and study how humans interact with AI at the individual levels. There seems to be this gap between understanding individual human behaviors and their experiences versus whether an AI systems and their applications would work or not work, whether they would cause harms or risk at the societal level. And so in today's talk, I'll walk you through a case study where we're looking at implementing large AI systems in the digital health and wellness space to give you a sense of some clues of where things might break down, where concerns might emerge. So you might notice that I'm using a lot of very inconclusive language here because this is very much an active research area that myself and a lot of other researchers have been exploring. And so some of these investigations that we started to see here, I hope they kind of provoke some ideas, some new thoughts and all that. But keep in mind, a lot of what I covered today, they might change, they might not be the most conclusive things that you'll take away in when we continue to explore this space in the foreseeable future. So before I dive into the case study, I want to first of all give you a sense of what do I mean by large-scale AI system, societal scale AI system, and the design of such system. So we'll start from, so in reality, when these large systems are deployed and implemented in our societal ecosystem, it starts from collecting data from a wide range of sources. It starts from collecting what we call pervasive data, which means data can pretty much come from everywhere and anywhere. To use these data, you can use them to train what we call intermediate AI systems to predict intermediate AI systems for prediction. And then building on top of these intermediate AI systems, you can build AI that perform more specific prediction tasks. And with such specific outcomes of such specific AI prediction, you can deliver, say, service, interventions, or treatments to a wide range of domains. I know this still sounds very abstract and conceptual, so I'll now put this into the context of health and wellness. So again, starting from the base pervasive data level, you can collect data from a wide range of sources and sensors. So that includes collecting, for example, location data, movement data, phone data, and also all of other data that can be tracked from your digital devices and all other digital outlets. From there, you can train AI, intermediate AI to predict to make what we call lower level prediction. So for example, with your GPS data, you can probably predict where someone is from your GPS data and say movement data that's tracked, say from your smartwatches. I can predict someone's activity type, what do they do, how active they are, do they get out of their bed and then do exercise, these sort of activity types. And based on these intermediate level type of predictions, you can predict even higher level behavioral markers. So let's say, depending on how active I am, depending on, say, signals from and other signals that I can extract from these intermediate level predictions, you can predict people's, say, their emotional states, how fatigued they are, or how much social interaction, social engagement are they connecting with other, with people in their own social cycles. And based on these higher level behavioral markers, that can be used to make very specific predictions, such as whether someone should be diagnosed as having clinical stage depression. So with this piece of information, of predicting whether someone, say whether someone is clinically depressed or not, you can then decide what sort of interventions you can deliver to your users, or your patients or pre-patients. And this includes the interventions, treatments, and services that can span a wide range of types and categories. So if we think about that in like the healthcare space, that can include really highly specialized healthcare types, but then that can also include interventions that happens at as what we call everyday wellness level today. So such as like helping you to monitor your sleep quality, sending you some nudges for going to bed on time, or tracking, say, your activity and eating behaviors. And so this is kind of the grand vision of how researchers and practitioners have been visioning in terms of societal scale AI in the digital health and wellness space. And if you look at some of the citations that I refer to here, it has been there for a while. It's not something that all of a sudden coming out with the recent popularity and interest in AI. And so these concepts have been proposed for a little while. And so in today's case study, I will focus on exploring what are the current practice? How far or how close are we from this grand vision? And what are some of with the current practice of how people are currently designing and implementing these large AI systems? What are some of the possible consequences that might come out of it? And so with this series of work, we first of all conducted 2 series of interviews and co-design sessions. We interview what we call ecosystem designers in this space. So these can be, for example, CMIO, health IT directors, and people who are working in major hospitals who are trying to roll out these sort of system design, and also rolling out how these type of systems can be implemented in the actual healthcare space. We also talk to providers, clinicians, physicians, those sorts, and also patients during the first series of our interviews and co-design sessions. And from there, we very quickly realized a lot of what's currently ongoing with the societal scale AI design in the health and wellness space. There are carried out not by providers, not by hospitals that much, and not by or not by government agencies either. But a lot of these design pieces are actually being supported or carried out by people who are in the consumer health tech space. So these are companies who are designing consumer health devices, consumer health applications. They're very much contributing to these space as well. And so we conduct another series of interviews and co-design sessions with people who are more in the business side and supplementing their perspectives with other health policy and responsible AI and ethics experts. And based on the insights that we learned from all these wide range of stakeholders, we also run additional ML experiments and simulation analysis to project some of the longer term, broader term concerns from their design practices. So I'll start, and then so that's kind of what we did in a nutshell, and I'll start from unpacking some of the takeaways that we have here. So first of all, as I mentioned, because a lot of design pieces that's rolling out in this space, they're actually being launched and pushed out by companies that are designing health tech devices, health tech applications. So I first of all want to kind of just lay out this what we call socio-business landscape that is pretty much a driver of what things are happening at the moment. And these companies, they are, first of all, they're motivated to match the product value that the value that their products can provide with, and match those values with people who can actually pay for these products, these health tech products and devices. They are also working under very tight timelines and pressure for deliverables. So you can imagine a lot of these health tech companies, they have pressures from their investors, from venture capitalists. And so they're really working on, they really need to think about what are like the most efficient way for them to gain insight, for them to gain performance outcomes that they can showcase to their investors. And finally, a lot of these consumer health companies, they're deeply interested not just in the consumer health space, they are interested in spending across the non-clinical and the clinical spaces. Of course, for market expansion motivations. And so when they're designing their devices and applications, they're very much thinking about where do we go from collecting data from one side of either the clinical or non-clinical world, and how do we spend from there to collect more data and to deliver more services and interventions to the other side of the market. And all of these motivations, interests, and pressure leads to a very iterative design and development process. And I'll give you a sense of what that chaotic process might look like. So regarding the first point where I mentioned about people have this strong motivation, these health companies, they have their strong motivations of finding what type of values can their products provide and what type of buyers can actually pay for the products and devices that they can deliver. On the left-hand side, you'll see a list of common healthcare benefits that can be delivered and provided by these new health technologies. And then on the right, you'll see a list of common what we call buyers, meaning people who can actually pay for healthcare and wellness services. So currently, also I want to make a note that our studies is very US centric. So a lot of the insight here is very much based on how the current US healthcare ecosystem work. But at least currently in the US healthcare ecosystem, most likely you will find your private insurer, your employer being probably the most stable and reliable buyers of these health products and services. And the type of healthcare benefits that they're most interested in is to treat short-term health outcomes, and also they're more interested in curing specific symptoms, specific disorders compared to taking care of people's long-term and preventive health benefits. And so from there, depending on who are paying for these health products and services, these different types of buyers, they seek different types of value proposition coming out from these health products and services. So for buyers from like the government provider sides and also some of the insurance side, they're more interested in what we call evidence-based value proposition. So for this, you can imagine they're really looking for hard clinical evidence to showcase that there is indeed certain degree of effectiveness coming out from these health technologies. Whereas whereas employers or patients and users who are paying out of their own pocket, they are interested in their own experience. They are interested in their experience as users. They're interested in their experience as patients, which very much goes back to, do I feel better from day to day as an individual? So this is what we categorize as user-centered value proposition. And depending on the type of value proposition that that these different buyers seek for, these health companies, they would go on to collect data and evidence to showcase the value of their health products and services. So for those who are looking for evidence-based value proposition, health companies are interested in running, say, clinical trials to collect clinical evidence. And for health companies who are targeting user-centered value proposition, they run series and series and series of user group studies to ensure their products is actually improving the everyday experience of these users. And for each of the routes, they might encounter challenge to stop at some point, which I will now show. So for those who are accumulating evidence through clinical trials, accumulating clinical evidence, a lot of times they stop going through their original pathway because they encounter obstacles, say essentially they run out of bounds, and then they encounter obstacles to collect new ways of securing funds, such as through new reimbursement codes from different insurance sources. And so with that route, they might repivot their products, repivot their technologies, and sell them to employers or individual users. On the other hand, for those who are selling their, positioning their technologies and services to individual users, that oftentimes encounter obstacles around scalability. And so from there, they might want to reconsider, can they go through other routes, such as selling to providers and private insurers. So this is kind of the current somewhat chaotic pathway that a lot of these health companies are going through. And frankly speaking, not all of these health companies have the money, time, or resources to go through so much trial and errors and then go through all these different paths to figure out who is their best, most valuable buyers and who can reliably pay for their health tech services. And so instead, these companies, they often ended up trying to, after they find out one single trials that work, they would focus their design and target their design to stakeholders who can target their design to people where they can reliably secure and source data from. And so to give you a sense of what that looked like, that include, for example, people who are targeting the user-centered evidence-based design. They are targeting at individual users, and they apply user-centered design to enhance user engagement of these individuals users with their health apps.
and then to secure more data from these individual users through their device and applications. On the other hand, for those who are targeting at the clinical route, they are interested in whether their products and services actually fit into the clinical workflows. And so again, these designers, these companies that are delivering products and services, they're applying user-centered design to fit their technologies with the clinical workflow so that they can more reliably source data from these clinicians and people who work in the clinical environment. And among the two, frankly speaking, we're seeing more of these health tech companies targeting more at the end users, those individual users for their design. And so there is this interesting contrast between where their grand value started with sourcing data from all possible sources and then delivering a wide range of services to different stakeholders, to different healthcare types. And all that comes down to designing their applications, designing their services, focusing on very specific groups of users and individuals. And so just to kind of reiterate that a little bit, this is the ideal version of where these companies started off. As I mentioned earlier, they want to build societal scale system from data coming from all diverse different sources from a wide range of categories, and then trying to deliver all different types of healthcare services to different individuals. But the current practices, they are sourcing data from very specific group of most commonly individual users or individual patients, and then using that to build specific AI models and systems, and then delivering specific types of interventions. If a companies have enough resources, they might repeat the process and then deliver the multiple different types of healthcare services, but each of them with specific unique AI applications. And so you might wonder, okay, so if this is the current status quo, if this is the way of how people get their job done, what's kind of like the problem with it? So there are a couple of areas of concerns that we started to see, and I will now move on a little bit to that. So first of all, with the current practice, there's a couple of consequences on the technical design decisions aspects. First of all, the grand vision of launching a societal scale AI, sourcing data from diverse source, delivering interventions to a wide range of healthcare categories, that will probably need to wait for a little bit based on the current practice. And so the ideal of delivering healthcare in multiple type of healthcare benefits in a more holistic fashions will also have to be put on hold. And then another issues with this current approach is, as you can see here, designers and these health tech companies, they're thinking about launching multiple apps, multiple applications, one at a time, which means you are delivering health service and benefits, just each of these health benefits just once at a time, which may potentially leads to more healthcare fragmentations in an already very fragmented healthcare space in the United States. And then also, because these design lines of launching and designing individual health technologies, health applications in standalone fashion, there is also oftentimes lack of planning and coordination across the ecosystem. A lot of time, patients would face, for example, frustrations when they are trying to move from the non-clinical space to the clinical space. They might face frictions when they are moving from one care type to another. And all of these can also potentially lead to tensions between providers and providers and also patients. To give you a sense of how that might influence healthcare individuals' healthcare experience. Here I'm showing an examples of a schizophrenia patient. They have like their ups and downs in terms of their symptoms severity. And so when they are experiencing more severe symptoms, that is when that triggers the need for going into receiving formal clinical treatments. But outside of those timeframes, they are very much relying on these consumer health or non-clinical health tech supports in their day-to-day basis. But because these applications are designed on a very standalone, on a coordinated fashion, and so imagine every time when the patient is moving from one care type to another, they have to switch to another app, and then another app, and then another app. And this is just one of the many symptoms or disorders that the patients might be experiencing. And so imagine if you're someone who have schizophrenia, you might also have comorbidity of other sorts. You might also have concerns with your other physical health symptoms and other mental health symptoms. And so this very fragmented and fraction process is just one of the many fragmented experience in your everyday healthcare experience. And all of these have the potential of leading to just in general more fragmentation in the healthcare space. Another point that I was trying to bring up was this potential tensions between patients and clinicians, given the current practice and design of these health tech apps and services. So first of all, patients themselves, they have very strong motivations to, they actually have very strong motivations to share more of their data with their providers in order to receive better quality of healthcare. But in reality, clinicians and physicians are often, they're burnout, they are very limited capacity to review and to process these additional data, these additional pieces of information coming in from these new pieces of technology. And on the other hand, there is also along the same line with patients' motivations to share more of their data in return of better health quality. That has a lot to do with potential of these data can be utilized to personalize your healthcare experience. But at least up to now, most the ways of how most of these AI applications and system functions, it's not the same type of the same degree of personalization of what most of the patients would imagine. Most of the times, these systems and applications are performing classifications or categorizations, trying to put people into buckets instead of the actual personalized healthcare that a lot of patients are imagining. So there is kind of this mismatch between what people are expecting given the data that they're sharing versus the actual services that they are receiving. And finally, patients, especially we've heard from especially patients who self-identify as minority individuals, they're very motivated to share more of their data because in order to improve knowledge, practice, and understanding of healthcare among their own communities. And because minority individuals are historically because healthcare, mental health care, physical health care are conventionally less studied among minority individuals compared to majority individuals. So these minority groups are more motivated compared to majority ones to share their data in order to improve healthcare experience and to kind of shrink this gap in terms of healthcare knowledge and practice. But when we talk to healthcare, public health and ethics experts, they have pretty split opinions on that. They raise concerns such as digital divides, in terms of whether people are actually having equal amount of access to these new technologies in order to actually contribute their data meaningfully, versus what types of patients are actually seeking and benefiting from these type of digital health, is an area that is pretty much still under debate. We also try to look at how does that influence healthcare experiences across different groups. And with that, we try to run simulation studies based on empirical data that we collected in the past. We try to train machine learning models based on these empirical data, and then trying to see, and then also trying to couple that with the insights that we get from our interviews and co-design sessions. So the empirical data sets that we use for simulations and trainings, these are a wide range of sensors data collecting from wide range of populations, and then these data and we have that sensor data alongside with their depression, with their self-report depression scores. And alongside that, we want to couple the simulation analysis with our insights that we learn from our interview studies, which the core part of those would include currently designers, practitioners are very much practicing user-centered design to enhance user engagement of these individual users, while these users, they're motivated to share their data as a pro-social behavior to improve understanding of healthcare knowledge and practices in their field, in their own community. And so keeping these in mind, I want to first of all kind of like walk us through two considerations. First of all, there is this considerations of increasing user space, increasing users who might join a pool of who might join the user pools of a health apps, of a health device. And so let's say we live in a world where the majority groups are the blue people and the minority groups are the pink people. And what we learn from prior literature is that when you started off with like having access to new technology for healthcare, usually there would be like more majority group people in the user base compared to minority group. And from what we learned through our interviews and insights that we extract from those qualitative legs of our studies, we know that the majority groups, they come with like a larger sample size, but then they also have like lower data sharing rate because they're less motivated to share compared to the minority group individuals who come from a smaller sample size, but then have very high data sharing rates. And so as more individuals join this user space, say for a particular piece of health app or health technologies, we started to see pretty much the performance of these models remaining similar for the majority groups because they have like a large sample size to start off with during their training process, and then they have like a good split between seen and unseen data. Whereas for the minority group, we started to see diminished performance of these models because when the models was previously trained, there was less unseen data due to the high data sharing rates and intentions from these minority individuals. So that's one of like the first considerations and kind of like the key takeaways that we get from the analysis. Another consideration is, so let's say now if we have a new policy that encourage everyone to share their data, which gives us two conditions to compare to. So that includes a baseline condition, which is kind of like the natural states where people decide on their own whether they want to share their data or not, versus what we call treatment conditions, where you have a new policy that mandates everyone to share all of their data, which in this case, you'll have people's data sharing rates being 100% for all groups. And we try to perform some analysis to look at how does that, what are some of the possible outcomes and consequences of that. So when we look at the performance of each individual AI systems for making clinical state prediction, whether or not people share all of their data does not significantly impact the performance of these individual single AI model. And we examined that by kind of like step by step removing different sources of sensor data. And so overall, there's no particular type of data being removed that would just drastically crash the performance of the AI models per se. But when we started to look at model performance, when these data are used to train not just the lower level prediction model, but also the intermediate and the higher level prediction models, we started to see we started to see a couple of trends here. So first of all, if you look at the top three, I would say top three rows over here, and the values, I realized I should probably include like the values, what these values represent in the graphs. But essentially, these are values coming from standardized effect, comparing how much errors decrease by using how much errors decrease compare the baseline conditions versus the interventions condition. So overall, having negative decreased values is actually a good thing because that means your model's performance have is making fewer errors. And so and these values are comparing looking at the difference between the interventions conditions versus the baseline condition. So if you look at the first three columns, I guess, well, maybe we'll start with like the first row. If we look at performance of the intervention condition at the whole population levels, without surprise, I guess, like if everyone's sharing their data, then your model's performance increase and the model makes fewer errors. And this trend also applies to the majority groups and the minority groups. If you look at all the majority people and all the minority people in your sample. What we started to see a little bit different is is in terms of model performance on those people who are already sharing their data in the control or the baseline conditions. So these are people who would share their data no matter what. They would share their data regardless of whether the policy mandates them to do so or not. These are people who would share their data regardless of what technologies they have at hand. And so it is with these people who are already sharing their data, hoping to improve the quality of healthcare and health knowledge in this space. We're seeing the model performance is actually making more errors with these particular group of people. And if we tie that back to our empirical insights from the interview studies, a lot of these people who would share their data no matter what are those minority and marginalized individuals who hope to improve health knowledge in their among their own communities. So that is another series of concerns. The very last point, I just want to maybe quickly point out that if we in terms of broader societal concerns, looking at the bird's eye view of the entire healthcare systems. Remember that when we started looking at the socio-business landscape, I was trying to lay out the types of healthcare benefits and like the people who and the buyers who might reliably pay for these different health benefits, which are essentially the determinants of what types of health products and services these healthcare companies would design their technologies for. And we very quickly noticed that for at least 4 major types of healthcare benefits, including public health, recovery health, preventive health, and also long-term health outcomes, because they're pretty much lack reliable
buyers in this space, and so health tech companies are much less motivated to design health technologies and design societal scale AI systems to resolve or improve health outcomes in these spaces, which is something that's lacking there. So up to here, these are all the content that I prepared for this talk. I want to leave some time for questions and comments, and thank you all for taking this.
I have a question. First of all, thank you so much for a really thought-provoking presentation. You know, that very last slide that you showed, where you were talking about the common types of health benefits and the possible buyers and the less sustainable market spaces. One of the things that I was struck by, and I wonder if this is something that came up in your interviews at all, if you're thinking about what digital health interventions or AI-driven interventions can do, they're largely tracking, monitoring, prompting sorts of things, which from my vantage point fits more into how people think about long-term health outcomes, preventive care, recovery care, public health, and curative care and short-term care are more things about, you know, you need drugs, you need a physical, medical device, not an electronic medical device that is primarily about information. And so I wonder if there's I'm wondering if that came up in your interviews at all, and if not, is this space even thinking about how marketable this universe even is?
Yeah, that's a really good point. And this is also I also see a lot of contrast between, for example, these 4 areas where people are not actively paying for healthcare or not having reliable healthcare buyers. These are almost the exact same categories of health benefits when these health companies are thinking about delivering like the grand vision of societal scale AI design, right? Because if we go back to like the very beginning where these people like penned out their grand vision, look at like the top type of like the categories of health services. Those are where they started with. Those are where they are thinking about, this is a more holistic approach to healthcare. They think about your everyday wellness, they think about preventing health issues, they think about long terms and all that. But many of these are pretty much they just didn't go through the funnels when these health companies are figuring out what's like the most effective pathway for them to design and deliver health products that someone would actually pay for. And
is there a self-awareness in that space of this conflict that you've identified?
Yeah, I think there is self-awareness, but there isn't much immediate reactions in terms of then what do we do about this? And so, quote unquote, from one of our interviewees, they literally say, but in order to like design healthcare in this space, in order to design new health technologies in this space, you almost have to be a health cynics to some extent to pretty much realize there are so much limitations in the current health ecosystems. And so that's kind of what we're hearing from our interviews. Yeah.
Interesting.
I had a question regarding the empirical study that you showed towards the end of the talk. And I think I might have, because I think one of the takeaways you mentioned was that like when the minority group was sharing information more than the majority group because they wanted to be like better represented in the data. Did you say that led to worse model performance for them later on, or?
Yeah, so that you can see that as that leads to like worse model performance on people who are already sharing their data.
Like if everybody should.
Yeah, so that's a comparison between the baseline condition and the intervention condition. So if you compare the intervention conditions where you kind of force everyone to share their data, that of course have positive benefits and positive outcomes when you look at model performance across the whole population level. But if you look at the model performance on those particular people who are already sharing their data in the baseline condition, they actually sees decreased performance in the model outputs because if you think about like the baseline condition, the model was very much tailored to the data that they're sharing, but then now the model has to also account for additional data that from people who would not normally share their data and contribute their data to the AI system.
Can you go to the like patient doctor attention side?
Sure, if I can call that. This is the one?
Oh, yes, and in the fairness and health equity. I wonder how like public health and ethnic experts help split opinion on this matter. Can you say more about it?
Yeah.
When it comes to like minority patient strategy.
Yeah, so to kind of unpack that a little bit further, there are a couple of different threads of thinking here. First of all, there's one big thread of thinking very much centered around the concept of digital divides, which goes back to the question of who actually have access to these digital technologies, these digital sensors, where you can collect data for digital health and for these AI systems to be trained on. So who actually affords the Apple Watch, who actually affords all of these like smart devices as sensors and sources where data can be collected. This is one area where people have questions around fairness and health equity or inequity. Another line of thinking is to think about who are already receiving and benefiting from digital health. And with that, you can think about who are already, say, receiving digital therapeutics, who can afford going to, say, a therapy session once or even twice a week on, say, additional platforms. Those are very specific group of individuals. And the comments that we hear from these public health experts and also ethics experts is around if we continue improving or carrying on the practice of the societal scale AI design or in general design of these health technologies, are we just continuing benefiting people who are already receiving a lot of supports in the current health systems, or are we actually expanding the reach and accessibility of these health services to a wider populations? And I don't think there's a conclusion on that at the moment. So that's why there's a lot of split opinions. Yeah.
Thank you for a fascinating talk. Can you hear me from here? That's a little far. So this is just so fascinating, but I was especially struck by this idea of scaling toward a societal level and thinking about that through the lens of science and technology studies, which tend to see scaling up as a form of an infrastructural turn of technologies. And this is a really fascinating illustration of how people are working toward that very an intensive system. But other than kind of thinking about how the models can endure over time and account for that and make changes, I was wondering if on your research, when you appear for data or on your own observations and thoughts, what do you think of sort of changes to the interfaces or the contours of the ecosystem? So for instance, the now we're seeing apps as really central to the ecosystem. And increasingly also moving toward a wearable-based paradigm of healthcare. And I was wondering how you make sense of that as a form of accounting for the changes to the devices and interfaces as we work toward a societal level ecosystem. For me, I see it almost like the next phase of redesigning an ICT ecosystem, or a next phase of digital transformation. In a sense, it's like you're in the early phase of re-infrastructuring until we reach a sense of stabilization. And I imagine in the case of AI, we're kind of at this stage at the moment. So I was just thinking about how do you make sense of sort of the device space and interface space changes that you're seeing alongside the sort of changes in data ecosystems themselves?
Yeah, that's a really thoughtful question. I guess like in terms of like time scale or like from like the longitudinal perspectives, I don't think I can say much about that because we conduct this series of work over about 2 years of time, but I wouldn't say that's long enough to make enough conclusion for especially in like the health tech space. What I can respond here is first of all, if we go back to like the key takeaway of these designers, these health companies, they're doing user-centered design for societal scale AI design. That's like the key message that we get from our interviews. They are already doing a fascinating job in terms of designing the app, designing the interface, designing the device with the main purpose of wanting to source more data from these from individual users. So I have no doubt, regardless of how the interface and device and design of these applications evolves, the logics or like the rationale of design will very much still centers around that, at least in a foreseeable future, because that's kind of their motivation of why they need these user-centered apps, right? So I think that's kind of my takeaway for that. I feel like there's like a second part of your question, but I'm not sure if I'm actually answering. Or maybe
No, this is helpful, sort of here, now grounding that in sort of the original motivation to the practitioners you talk to. And I guess I'm thinking about this just on the broadest level, is like us as a society, how are we moving forward in these infrastructure level technologies? And yeah, just thinking about sort of the changing contour of what we see, despite sort of perhaps we're still using the same data sets and we're improving the models, but everything around it sort of is also changing too.
I think at the societal level, I'll go back to my earlier comment around healthcare fragmentation. So, and as I mentioned, I think designers are already doing a great job in terms of designing apps and app services that really engage with users to source data. But how do we further ensure that efforts is coordinated across, say, design of different health apps and say design of different healthcare infrastructure? So maybe to give you a more concrete idea, if I'm say measuring, say, like my blood pressure or like heart rates or any sort of these data through my smartwatches, is that metrics, the way of how data is logged, how data is stored and formulated, is that the same way as how, say, a clinical lab is currently doing it? So that if that level of coordination happens, that might minimizes the pinpoint of what I showed earlier in terms of patients have to keep going through new apps, new applications, new device when they transition from one health environment to another. I feel like that is more of a societal level type of things that can be improved. How do we start? I also don't have a good answer to that. Another examples that we hear from a couple of our participants is around this idea of designing healthcare metrics. So for example, currently, at least if you look at the clinical side of things, metrics are designed very much in order to for reimbursement or EHR, EMR reimbursement systems. And so how do you move from that to say more health focus or more user focus? I think that's also something that that won't happen unless there's societal scale coordination. Yeah.
It's 3 o'clock, so if you can all join me in another round of applause for Dr. Hwang. And so if you have any last minute questions that you want to ask her, she'll stick around for a few minutes, but otherwise, thank you for joining our seminar this afternoon.